Today we're covering section 3.3. We're talking about when functions are increasing and decreasing. So as far as a description, a function is increasing on an interval if the graph is rising from left to right. Now that'd be like a positive slope, even though these are talking about curves. That's not a definition, but that's a description, just so that we can keep in mind what's going on with the picture. A function is decreasing on an interval if the graph is falling from left to right. So that would be like in a certain area if it looked like kind of like a line where the slope was negative. Now our actual definition, f is increasing on an interval if, or on an interval I, if f of x sub 1 is less than f of x sub 2 whenever x sub 1 is less than x sub 2 in the interval. F of x sub 1, remember that's just referring to the y value, what we would normally call that, so that's the up and down stuff. So again, just to get an idea, if this is x sub 1 value and this is x sub 2 value, what we're saying is this would be f of x sub 1, and if the function is increasing, f of x sub 2 would have to be greater than or higher than f of x sub 1. Our definition for decreasing, just the opposite. We would say that f of x sub 1 is greater than f of x sub 2 anytime that x sub 1 is less than x sub 2 on that interval. So, as we look at this one, we want to determine the intervals on which the function below is increasing and the intervals on which it is decreasing. So as we look at this, considering this line right here, you can see it's going up from left to right. So we would say that one is increasing. And the interval on which it's increasing is from 0 right here to 2 right here. So the way we say that is it's increasing from 0 to 2. Notice in this area right here, it's not increasing or decreasing, so we're not going to even think about that. From 3 to 4 is the next interval that we can look at. And as we look at this one, we can see that that function is decreasing. And then finally, as we consider this area, even though it's not a straight line, the function is still increasing. So the interval from 4 to 6, that function is increasing. So looking at a picture, that's how we describe it. We just look at where is the graph going up from left to right and where is the graph going down from left to right. Looking at this one, given the function below, first of all, find the domain and the range. Now remember, in a function, the domain is all of the x values that get used. And as we can see, this thing, it doesn't stop here on the left-hand side, and it doesn't stop here on the right-hand side, and there's no values where it's not defined, so our domain is simply all real numbers, or we can write that as from negative infinity to positive infinity. We can use anything. The range, on the other hand, as we look at this, it looks like we've got right here, and you can't maybe see that very well, but we've got a horizontal asymptote at 0. So it looks like our range, the lowest value that we get for the y values is right down here at -2. The highest value is right here at 0. So we would say that our range is from -2 to 0. And notice that the -2, it does reach that value of -2, but it never gets to 0. So that's why we have a bracket here at the -2 and parentheses on the 0. When we talk about average rate of change, you're going to kind of recognize this formula, but the average rate of change of a function between x equals a and x equals b is given by this formula, f of b minus f of a divided by b minus a. This looks kind of familiar, it should, because it's really just the slope formula. That's what you do for the average rate of change. F of b is simply a y value, f of a is a y value, b is an x value, and a is an x value. So this is really just the slope formula, and this is something you're going to have to know. So I would, as I'm thinking about it, I would just view this as the slope formula and deal with it that way. So average rate of change is the slope of the secant line between x equals a and x equals b on the graph of f. In other words, that's the line that passes through those 2 points, which we just talked about. It's the slope of that line. So for the function f of x equals x plus 2 squared, find the average rate of change between negative 2 and positive 2. So if we use our formula, that is f of 2 minus f of negative 2 over 2 minus negative 2. So we have to figure out what f of 2 is. So remember that f of 2 means that our input value is 2. So it's going to be 2, replacing that x, plus 2 squared. And that is 4 squared, which is 16. So right here, our first value is going to be 16 minus. Then we also need to know what f of negative 2 is. We have to know both of those. So f of negative 2 is going to be negative 2 plus 2 squared. And negative 2 plus 2 is 0. So when we square that, we get 0. So 16 minus 0 on the top, and 2 minus negative 2 on the bottom. That's the same as adding a positive 2, so we get 4. So our average rate of change there is 16 over 4, which is 4. For part B, we're doing 2 different x values. So again, set it up, f of 10 minus f of 3 over 10 minus 3. So again, we need to know what f of 10 is, first of all. So we've got to know this. So f of 10 is 10 plus 2 squared, and that is 12 squared is 144. So that goes in right here, minus, and when we put in a 3, f of 3 is 3 plus 2 squared, and that is 25. Put that in there, and then 10 minus 3 is 7. So 144 minus 25 is 119 over 7, and when we divide 119 by 7, that gives us 17. So our average rate of change there is 17, 119 divided by 7. Example 4, an object is dropped from a tall building, then the distance it has fallen after t seconds is given by this function, 16t squared. Find the average speed over the following intervals. When you talk about average speed, that's really average rate of change, right? That's what a speed is, like miles per hour. It's the change in miles per hour. So this is really the same type of problem. So when we look at between 1 and 5 seconds, we need to have, in this case, d of 5 minus d of 1 over 5 minus 1. So d of 5, we plug in a 5, it's 16 times 5 squared, which is 16 times 25, and that is 400. And then d of 1 is 16 times 1 squared, which is 16. So here we have 400 minus 16 over 5 minus 1 is 4. And when we divide that, we get 96. So 96, this is, they don't give us any units. 96 is the average speed there. Now when we look at this one, between t equals a and t equals a plus h, I hope I have enough space here. I'm going to start over here. So d of a plus h minus d of a over a plus h minus a. All right, so again, we have to figure out what d of a plus h is. I'm going to go up here and do that. d of a plus h will be 16 times a plus h squared. Remember, we have to FOIL that. Now, I'm pretty confident you guys are able to FOIL at this point, so I'm just going to write down what this is going to be. It's going to be a squared plus 2ah plus h squared. So when we distribute that 16, it's going to be 16 a squared plus 32ah plus 16h squared minus, when we put in an a in place of the t, notice the only thing that changes is we're going to have 16a squared. And that is all over a plus h minus a. Notice the a's will cancel, and we just have h on the bottom. So now, we just have to simplify. We don't have numbers to plug in, but we've got to simplify. The 16a squareds will cancel, and so we're left with 32ah plus 16h squared. But notice again, we can factor, and in this case, factoring out an h is really what we want to do, because that h will be able to cancel with the bottom. So we're going to have 32a plus 16h over h, and that will cancel. So our final answer here is this expression, 32a plus h. So in other words, if you know the point that the thing started falling and how long it fell, you'll be able to plug it into that little formula there. It's a general formula, and figure out the average speed over that rate of time. Okay, we're going to have a table here in just a second. The table gives the outdoor temperatures observed by a science student on a spring day. Draw a graph of the data. We're actually not going to draw the graph. And find the average rate of change of temperature between the following times, from 8 to 9, from 1 to 3, and from 4 to 7. So here is our table that we're going to use to answer those questions. So first of all, to set up the first one from 8 to 9, remember that means we're going to need, we'll just call it f of 9 minus f of 8 over 9 minus 8. So at 9 o'clock, the temperature is 40 degrees, so we just plug that in for f of 9. No work there. At 8 o'clock, the temperature was 38 degrees, so we plug that in. And then 9 minus 8 is 1, so our answer is 2 degrees per hour, which makes sense since it was only 1 hour and it changed 2 degrees. From 1 to 3 o'clock, we need f of 3 minus f of 1. And that's going to be over 3 minus 1. So at 3 o'clock, the temperature is 67 degrees. And at 1 o'clock, the temperature is 62 degrees. And 3 minus 1 is 2. So this gives us 5 over 2, which is 2.5 degrees. Again, that's degrees per hour. It's an average rate of change. Our last one here, again, to set it up, f of 7 minus f of 4 over 7 minus 4. The temperature at 7 o'clock was 51 degrees. The temperature at 4 o'clock was 64 degrees. And 7 minus 4 is 3. So 51 minus 64, this one's a little bit different. We're going to get a negative 13 over 3. That gives us an answer of negative 4.3, repeating, degrees per hour. Notice this one is negative because between 4 and 7 o'clock, the temperature went down. So the average rate of change is a negative temperature. Before, in all the other intervals, the temperature was increasing. So that's why it was positive. Example 6. Let f of x be this function. Find the average rate of change of f between the following points. So, again, starting with this one, we need f of 1 minus f of 0 over 1 minus 0. So f of 1, I'm just going to plug that in. We can think about it. Negative 4 times 1 is negative 4 plus 12. That's going to give us 8. So if we want to see that, f of 1 is negative 4 times 1 plus 12, and that is 8. Minus f of 0 is negative 4 times 0 plus 12, and that is 12. Over 1, and that gives us negative 4. Average rate of change there, negative 4. For part B, f of 7 minus f of 3 over 7 minus 3. Again here, f of 7 is negative 4 times 7 plus 12. That's negative 28 plus 12 is 16. F of 3 is negative 4 times 3 plus 12. Can't see that very well, but that's 12. Negative 12 plus 12 is 0. Over 7 minus 3 is 4. And notice, what do I have wrong here? Oh, sorry, this is negative 16. Negative 16 over 4 is negative 4. So both the answers for A and B were negative 4. Now let's look at what happens with this one. So again, we need f of A plus h minus f of A over A plus h minus A. So again, the a's will cancel. We'll just have h on the bottom. I've got some space over here, so let's just do this work here. F of A plus h is negative 4 times A plus h plus 12. That's negative 4a minus 4h plus 12. So I'm going to put that in right here. Remember, that replaces this one. And then f of a, negative 4 times a plus 12. Well, that's pretty easy. Now, what happens here is we do have to be careful because we're subtracting this, so it'll be minus 4a plus 12. And this is all over h. So as we begin simplifying this, notice we want to distribute this negative to here and here. So we have negative 4a minus 4h plus 12 plus 4a and minus 12 when we distribute that negative. So what happens here? The 12s cancel out, the 4a's cancel out, and we are left with 4h over h. Then the h's cancel out. Oh, sorry, I missed this negative. Negative 4h over h, and we're left with negative 4. So what conclusion can we draw? Well, since this is the general case, it doesn't matter where we're looking. The average rate of change is always negative 4. We got that answer for every one of those. And the reason is, if you think about this function, and we should recognize this, this is a line, so the rate of change is never changing. It's always got a slope of negative 4, and that's why our average rate of change is always negative 4. So looking at our assignment here, these are the problems you should take a look at. There aren't too many of them, and average rate of change is really pretty basic and pretty simple. It boils down to being slope, and so if you can find slope, you can find average rate of change. So take a look at those, and again, you'll have time in class tomorrow to work on them some more and to ask some questions.